All right, guys, so I want to talk about two things in this third video here, grounding and conduction, because they're basically reverses of each other, and that's why they should be explained together. So grounding, it says here, is a way to get rid of excess charge. Pulls up charges to neutralize a positive object. It sends electrons down to neutralize a negative object there. So let's show you what we mean by that. So another word for grounding, the key thing here could be neutralizing. So let's say here we have this positively charged piece of metal and you touch it. Those positive charges are going to pull electrons in from your hand until this thing is neutralized. So again, a positively charged thing, it attracts the electrons because only electrons move out of your hand and into this electroscope, it's called, and so it neutralizes it. Now, the reason it's called grounding is if this was a strong enough charge, I'm trying to say, then it could actually pull electrons all the way through your body from the ground. The ground has basically an infinite amount of charge, so it's never really affected anything. So that's why it's called grounding. It's important to note here that the positive charges didn't leave this and go into your hand because that's impossible. Positive charges don't move. So what about grounding a negatively charged object? Well, then these extra electrons would flow out of the piece of metal and into your hand and potentially all the way to the ground, hence grounding again. So again, you touch the negatively charged object, and if you give it a path to the ground, then the electrons will flow. So you have to have contact to the ground actually to make this one work. It has somewhere where it has to go. If you fell out of an airplane and grabbed onto a power line, first off, they're insulated most of the time, but let's say it wasn't, it was just bare metal, you'd actually be okay. You wouldn't get electrocuted until maybe like someone came up with a fire truck ladder and tried to grab you. Then there would be a path from the wire down to the ground and electricity would start to flow, just like in this case right here. So then you would be grounded and it would go out of you. So let's say that you do this. You take a negatively charged object, you touch it to a neutral object, electrons will start to flow from the negatively charged object into the neutral object. Then they will spread out, if it's metal, all throughout here. It won't work very well if it's an insulator. An important thing here too is that this thing is still negative. It's not neutral now. Some people think, oh, it lost all its charge. All the charge jumped in here. But that never actually happens because then this thing would be the negative thing and the electrons would just flow right back into the neutral thing. So it goes until there's a distribution, and it depends upon their sizes and things like that, how much it splits between the two objects there. What about if we did it with a positively charged object? So here we have a neutral sphere. Here we have a positively charged pie plate, and this is a styrofoam cup, keeping it insulated. Electrons will feel the pull of this positively charged pie plate and start to flow into that metal. Because electrons are leaving the sphere, that makes the sphere positive in the end. Again, don't say positive charges jumped from the pie plate into the sphere. That's not what happened. Only the electrons can move. The electrons move from the sphere into the pie plate. And now notice the sphere is now positive, just like the thing that touched it. And the pie plate is still positive here. I would show you the Van de Graaff generator. Maybe I'll make a video. I got to go into school and take down the posters, and maybe I'll get it out then. I would have shown this in class. You can watch videos online, but it's a shame that we can't do this part here. Anyway, an important thing here is that insulators will not charge by conduction. So if you took a metal pie plate and put it on a charged piece of plastic, it will polarize it like we talked about in an earlier video, but charges won't be able to actually flow into the plate, or at least not very much, because the charges are bound in the plastic because it is an insulator. It doesn't easily let go of its charges. Now, if it was rubbed, then maybe you can get some charge off of there. Sometimes you'll even get some charging by lightning. Even if you never actually touched, you'll hear a little spark and electrons will jump through the air from a charged object to a neutral object. So that is it for this video. I will see you guys on the next video.